Hello everyone. In this video, we're going to continue with dual numbers episode 2. So if you remember, in the first video, we talked about definition of dual numbers and we said that a plus b epsilon is a dual number if a and b are real numbers and epsilon is such a number that epsilon squared is equal to 0. But at the same time, epsilon does not equal 0. So it's a weird number whose square equals 0. You can also think of it as an infinitesimal. Now, in this episode, we're going to talk about different functions, and we're going to try to make it more and more complicated. So let's go ahead and take a look at two types of functions today. We can actually do more on this, but let's go ahead and start with the exponential function, which is f of x equals e to the power x. So what happens if f of x is e to the x? In other words, from here, how do you evaluate f of x plus epsilon? Because that's what we've been trying to do, right? With any function, and we had a formula, if you remember. One of the main uses of dual numbers is that automatic differentiation, okay, in computer science. So let's go ahead and break this down. If f of x is e to the power x, then what is f of x plus epsilon, right? So by definition, f of x plus epsilon is going to be e to the power x plus epsilon. And then, obviously, because the exponents are added, we can go ahead and split these up into two pieces, e to the power x times e to the power epsilon. So e to the power x is just a function, but let's go ahead and break this down. But how do you break it down, right? How do you simplify e to the power epsilon? And there's a really cool way of doing it. It's an exponential. The power doesn't make sense, does it? It's a number whose square equals 0, but the number itself is not equal to 0. So we can actually use Taylor series again for this one. And if you remember, e to the power x can be written as 1 plus x squared divided by 2 factorial plus x to the third power divided by 3 factorial, so on and so forth, right? Now, we're not going to substitute this for e to the x, but we're going to use it for e to the power epsilon because e to the power x can stay as is, okay? But let's go ahead and replace x with epsilon so that we can evaluate e to the power epsilon from here, okay? So now we're going to replace all the x's with epsilon. It's going to look like this. 1 plus epsilon squared divided by 2 factorial plus epsilon to the third power divided by 3 factorial, so on and so forth. But if you pay attention and remember the definition of epsilon, you realize that, okay, epsilon squared is equal to 0. And of course, epsilon cubed is also 0, needless to say, right? Because epsilon cubed is made up of what? Epsilon squared times epsilon. Since this is 0, the whole thing is 0. Any power, starting with the second power, they're all zeros. So we kind of end up with something super duper nice. E to the power epsilon is equal to 1 plus epsilon. Nice, right? So we have an exponential, but we can kind of linearize it. And any exponential can be done in a similar manner. Later in the third episode, we're going to actually look at more complicated cases. But let's go ahead and continue with this because we're not done yet, right? Our goal is to evaluate f of x plus epsilon. And what we found is just e to the power epsilon. So let's go ahead and plug it in. F of x plus epsilon was equal to e to the x times, if you remember, e to the x times e to the epsilon. And now we're going to replace e to the epsilon with this, right? 1 plus epsilon. And what that gives us is actually amazing. Verifies the formula one more time. Remember what we said? When we have f of x plus epsilon, that gives us the function and its derivative. Do you remember the formula? The formula was like this for any function that is differentiable, of course. F of x plus epsilon is equal to f of x plus f prime of x times epsilon. So this is a single equation that gives you the function itself and its derivative at the same time. That's why it is so powerful, right? Now, let's go ahead and see if this is verified. Of course, we're going to use distributive property. So this is going to be e to the power x times 1, which is e to the power x. And then plus e to the power x multiplied by epsilon. It's going to be e to the power x times epsilon. And guess what this is all about? F of x is e to the x. and its derivative is also e to the x. Again, it's been verified one more time for the exponential function. Does that make sense? All right, great. Comment if it does. I mean, even if it doesn't, you should still comment down below. Great, let's go ahead and take a look at something else now. So, and that'll be the natural log function. Okay, great. So let's go ahead and take a look. Suppose we have f of x equals ln x. Ln x is differentiable, right? Obviously. The question is, what is f of x plus epsilon, right? And you can write it like this. F of x plus epsilon, easy, right? Just replace x with x plus epsilon. But we kind of get stuck here. Because how do you simplify this? You cannot use ln on a sum because there are no identities. Yes, we can ln a product, we can ln a quotient, but the sum doesn't really help, right? So what do? Well, here's what we're going to do next. We're going to go ahead and, not for this, but for any dual number, we're going to try to ln a dual number. If you know the ln of a dual number, obviously, we can also do this, can't we? By using that particular formula, right? Okay, let's go ahead and take a look at the ln of any dual number, which we can write as a plus b epsilon. Again, a and b are real numbers. Guess what? We are living in the dual number world, just like the complex number world, right? Remember? By the way, speaking of complex numbers, I have a channel dedicated to complex numbers, a plus bi, and I'm going to announce the new schedule this Friday, probably. In a couple days, I'm planning to announce the new schedule for my channels because I have 3 channels and it's really hard to manage all of them. Anyways, now, how do you ln a dual number? Well, we're in the dual number world. Therefore, the ln of a dual number, just like a complex number, will be a dual number. So let's go ahead and write the ln of a plus b epsilon as c plus d epsilon. Okay? Our goal is going to be to find c and d in terms of a and b so that we can write the ln of any dual number as a formula. Okay, ready? Now, we don't know how to simplify this because, again, we get stuck with the sum. But wait a minute, all hope is not lost. What we can do is we can revert this, right? Or reverse this. How do we reverse this? By using the definition. So you know that the base is e. So why not use the definition of logarithms? Because we have a formula for exponentials, we can definitely use that. So from here, we get that e to the power c plus d epsilon is equal to a plus b epsilon. Again, if you exponentiate a dual number, you get another dual number. And you can go back and forth with this. Make sense? Now, let's take a look. We can split it up or we can just directly use the formula. What is e to the power c plus d epsilon? Do we have a formula for that? No, but that's okay. We can still do it. E to the c times e to the d epsilon. And then we can go ahead and keep the e to the c. And for this part, because this is just a real number, normal number, if we don't have any duality, we can just use it on the second one. And by the Taylor's formula, there's going to be 1 plus x, remember, that's d epsilon, plus the x squared divided by 2 factorial, x cubed divided by 3 factorial, and so on and so forth. But again, you don't need anything besides the second power because they're all zeros. Uh-oh, this is really cool, isn't it? This gave us e to the c times 1 plus d epsilon. But we were looking for this, right? So very cool. In other words, if you distribute this, remember, this comes from the left-hand side, and this is the right-hand side. So now we're going to set this let me write it down one more time before I distribute. And on the right-hand side, I have a plus b epsilon. Again, our goal is to solve for c and d in terms of a and b. And it's going to be awesome. Let's go ahead and distribute. We get e to the power c plus e to the power c d epsilon equals a plus b epsilon. By the way, you don't have to do it that way. You can also factor out an a here and write this as 1 plus b over a epsilon and also solve it that way. It's probably going to be a little easier, but I wanted to do it this way. Now, we're going to compare the real parts and the dual parts. Is that what it's called? Probably. So from here, we get e to the c equals a, which means c is equal to ln a, just like natural log, right? And then this is equal to b. e to the cd is equal to b, because that's what the dual parts are. They're supposed to be equal, right? Otherwise, these two numbers cannot be equal. But we know that this is already a. So from here, we get ad equals b. And we're looking for d, so it's equal to b over a. So we got c in terms of a, d in terms of a and b. We're good. Now, what was this? Where did this come from? It comes from here. We assume that ln a plus b epsilon is c plus d epsilon. Now we're going to replace, are you ready for this? C with ln a and d with b over a epsilon. Awesome. So to ln a dual number, you have to ln its real part plus divide the dual part by the real part and then multiply by epsilon. That's going to give you the dual part. This also explains why ln epsilon does not exist, which is a video that I made as a video response to Black Pen, Red Pen a while ago. I hope you also check that out. So this is going to be the third video on dual numbers, and I'm planning to continue them as long as there's interest. Because when I did the first episode, I didn't really get that much interaction. Hopefully this time I'll be getting more interactions. So what was our goal? Our goal was to get something like ln x plus epsilon, right? That's our goal. Remember that. Don't forget. But as a bonus, you did get a formula for the ln of a dual number. Now, we can definitely use this to find the ln of any dual number, including x plus epsilon, even though x is a variable. What we need to do is replace a with x and b with 1, right? That's what it is. So if you replace a with x and b with 1, you're going to get what? ln x plus 1 over x epsilon. And one more time, ta-da-da-da, the beautiful formula works, the magical formula works. This is ln x, and this is the derivative of ln x. One more time, it gave us the function and its derivative. And this brings us to the end of this video. Thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time in another video. Until then, be safe, take care, and don't forget to check out SyberMath and aplusbi, and bye-bye.